Wow, this is a big crowd. Well, welcome to this session for where we'll be talking about Microsoft's IoT vision. I am Arjuman Samuel. I am from the Azure IoT team, and I do security and privacy on the team. I lead that effort, which includes the devices, connectivity, and the cloud services. But today I'll talk about the vision that we have. And specifically, I want to talk about the transformation that is going to happen in business and how IoT is going to be a driver for that transformation. Many companies today do not think about themselves as IoT companies, but many companies do not even think about themselves today as software companies, right? And that is where I would like to put Satya's face up there, just because I wanted to. Something over there is interesting, right? Every business will have to transform to a software company. That's interesting. And if you think about it, software is really the driving force of a lot of transformation happening today in business, right? And I would argue that IoT is part of that transformation. IoT is the driver for that transformation, especially if you are a company with anything which is physical. And I believe many or all companies have something physical. It could be a widget which you make. It could be a widget that you use. It could be a widget that you sell. It could be a widget that you use just because you ship something using something, right? So in some way, you are associated with IoT. You might not know about it today, or you might. But I would like to talk about how IoT is that driver for transformation. Now, there are some numbers here. It's a third-party survey that we did a while back. Talk about some big numbers, but something to think about is that in the next 4 years, we are actually going to get 30 billion devices on the planet, connected devices on the planet. It's a huge opportunity waiting to happen in the next few years. It's already started, and we are already seeing that happen. And that opportunity means whoever is going to become that software company is going to be a successful company, and anybody who does not is going to be left behind. How I'm going to structure our conversation in the next 40 minutes or so is that I'm going to talk about the transformations that have happened with our partners. I'll select a few stories. I'll tell you what they did, how they went about transforming their businesses using IoT. All of that with a goal to talk about the key learnings that came out from there. So if you are thinking about that transformation, or your partner is thinking about that transformation, or a customer is thinking about the transformation, what are the key things that should be on top of mind today, right? So I've distilled that in 2-3 things that you should think about. And then I'm also going to talk about some of the challenges, right? It's not all cool and geeky and fun to connect devices with IoT and then everything just happens. There are a bunch of challenges that we all have to think about, both in terms of how you deploy devices, how you manage devices, what is the security for those devices, the questions of privacy for those devices. All of those are big challenges, and I'll talk about those. And then finally, I'll talk about some of the offerings that we have as a company, Microsoft, and I'll talk about what we offer so that your journey towards becoming a software company, a software IoT company becomes easy, becomes just something that you can achieve. So that's really what we'll talk about. If you have questions, if you can't hear me, interrupt me, and I'll speak louder. I can speak pretty loud. And if you have questions, I'll love to take them. Yes?
What is IoT?
Great. Thank you. So the question here is, what is the Internet of Things? I think that is a great question and a great way to start here. So many people would define IoT differently. That's the interesting part, and I think that's where this stems from. All of these devices which now we see are being connected to the network, and the intelligence that we get from all of these devices being connected together is, in a sense, the Internet of Things. Now, when I say devices, what does that mean? What devices? Well, devices could be anything. Devices could be my shirt, right? My shirt, it doesn't have, by the way, my shirt could have a sensor on it which is monitoring things happening inside of me and pumping that data somewhere, and there is something happening there. The band and other variables that we have today are all IoT devices. Devices could be thermostats and temperature sensors and occupancy sensors deployed in buildings. Devices could also be aircraft. Devices could be aircraft engines with a bunch of instrumentation and a bunch of data that is being collected from there. So all of these devices are already in our environment. And with silicon, the cost of silicon going down, expect more of that to come in. Expect your chair to be an IoT device, right? When you sit on it, it knows who you are, it adjusts according to your preferences. That is an IoT device. So anything with some intelligence to be able to either collect data or to act in that environment and to be able to send the data to another device or the cloud are all IoT devices. Right? So thank you for that question. Why do we say that IoT is the driver for digital transformation? We did a survey with a third party. We went out and talked to a bunch of people companies who are thinking about how does that transform me? How does that transform my company? And there are a few interesting statistics here. The last one is really interesting. And these are people who were looking at their operations, and they realized that if they had IoT, meaning if they had sensors and devices which would monitor what is going on in their environment, they could probably reduce the downtime by 50%. Right? Now, what does that mean? That means you have your whatever service or whatever physical thing you provide to your customers, you have more of that, 50% reduction in downtime. You also have a more satisfied customer, 50% reduction in downtime. You also have more revenue, because satisfied customer means more revenue. And above all, and this is interesting, you also could evolve your business models. Your businesses could change. And I actually have a few examples where the companies that we worked with evaluated what they were doing, and then they thought about it, stepped back and thought about it, and realized there is a new business sitting right over here. And that, is the transformation that we are talking about. And here are some of our partners, and these are some of them, obviously not all of them. These are the people who allowed us to put the logos up there, but also tell a story. Now, these Rolls-Royce, I'm talking not about the cool luxury cars, though they are also IoT devices. I'm talking about the aircraft engines. Right? Aircraft engines have a bunch of instrumentation on them. If you could aggregate all of that information, the data that engine is generating, bring it together somehow, run machine learning, and then look at what optimizations you could do to that engine, could you predict something about that engine? Rolls-Royce found out that they can actually save $250,000 one plane in a year, just on 1% of fuel saving. So huge saving here, and also I'm not even talking about safety, right? That in itself is huge in this scenario. The other company over here, which I'll just briefly mention, is ThyssenKrupp. I'm not sure how many would know about that company, but when I tell you what that company is about, it's about elevators. They are a large elevator manufacturer. They have something like 1.5 million elevators deployed around the world. And they are under a lot of pressure to keep those elevators maintained. So they maintain them. So in each big city, they have a contractor whom they work with. The contractor would go to the building, fix the elevator. So the elevator breaks down. You have that yellow tape put in front of it, and then tomorrow or day after or next week, somebody will come in with a toolkit and will start meddling with it, and hopefully it would start working. So that was the pressure on them. All of their business model was, we need these elevators to be available for riders to use them. And so they came to us, we started working with them, and we took elevators with them, and they installed sensors on almost all moving parts, including occupancy. How many people step in? How many rides does the elevator take? What is the tension on each string? What is the vibration on each bearing? right? And what is, so they put a bunch of sensors, they put a gateway in there, a GSM-enabled gateway, which pumped the data to the cloud. They set up a control center where all of this data would come in. They would run machine learning in aggregate because now they're getting data from multiple elevators, and they discovered some interesting insights, which they just could not discover only based on that one elevator, which broke down. For example, initially they thought that the occupancy, more number of people when they step in, that is a tension on the bearing, and so it breaks down. They realize that it's also that, but a very close following that is the number of trips. Even if one person steps in and takes 10 trips, that bearing is under stress. And so there's a better correlation between it breaking down than the number of people stepping in. Right? So those were the kind of insights that came about when they looked at this data in aggregate. And then, based on data that they could see, they started thinking about, can I predict when this bearing will fail? Because if I could, I actually could go in at night when nobody is using it. I know that tomorrow the bearing is going to fail. So yes, or today evening, I'll send somebody to simply replace the bearing. And so the downtime was reduced substantially. Right? So the downtime was reduced substantially. You have a happy customer. But then it went beyond that. That's about transformation, right? So it's about data. It's about looking at those insights and understanding what is going on with my widget, which happens to be an elevator. But more than that, the building owners said that, you know what? We'll not like to buy elevators. We'd rather lease elevators. A different model, right? And so leasing elevators meant that now this company was responsible for its uptime. And the more it is available, the better they can earn out of it, earn money out of it. So they had better insights into their operations just because they deployed IoT on that device. They could predict failures just because they had IoT on the device. And they could transform themselves into a different kind of business, which otherwise wouldn't have been possible. So another example, now I'm going to refer to it on and off as we proceed, but there are others also right over here. You replace elevator with a car, same thing. You replace elevator with a jet engine, same thing. Insights, prediction, and all of those things come in when you have data in the aggregate. So what does it mean? What is the real world use case, right? How do I, is that the only one, the elevator and then the jet engine? Actually, when we look around, there are all of these use cases, and you'll recognize, yes, the dog is there, and the aircraft is there, and the smart grids are there, and the mining and the engines and the smart meters and the post boxes and the medical device, all of them are there. All of them are there. And so are cows, right? So there are farms now, experimental, granted, but there are farms now which actually put sensors on their cows just to predict the behavior of the cow and do interesting things with that, right? So, and all of this is off-the-shelf sensors, not very expensive sensors, it's connectivity, and then those farms become IoT farms. Right? So these are some of the use cases. You'll recognize some would be a surprise. By the way, there is, the band and all of these fitness things that are available for humans. Did you know there is now a collar for a dog? With the same kind of functionality, it detects how much it has run, it detects how much, and the key selling point there is never lose your dog. There's a GPS, right? So if the dog is lost, you get your app out and you know exactly where the dog is. It's like Uber for dogs. Anyway, so that's what is the transformation that is happening around us. New business are coming up who are going to use this new IoT phenomenon to create new value. Existing business are coming up and looking at their business models and evaluating if they could go to the next level and do things more efficiently, do things in a better way. Okay, so what I've done here in the next 2-3 slides, I have a bunch of industry-specific, vertical-specific use cases. I'll not go into all of those, but just to mention what those are, just to give you a flavor of how IoT is changing business today. Right? The goal is that in some of those verticals, you'll probably see some of your partners or yourself, or somewhere you'll see that. And by the way, all of these that I'll show are case studies, which we have done with our partners, are available for you to read, and I'll, towards the end, give you a URL so that in case you're interested in any one, you can go deeper into it. So the first one here is manufacturing. We talked about Rolls-Royce. Rockwell Automation is another example. These are these huge pipelines, oil pipelines, which are pumping right from where oil is discovered and pumped from the ground to the refinery, which is thousands of miles, goes all the way to the end consumer through a pump, and all of this is automated using their equipment. And so now they have a real-time insight into what is happening in the whole supply chain. They can optimize it. They can actually dial things up, dial things down, and control how the whole operation works, all in real time, and learn from it. So there is machine learning, which allows them to learn from it. I mentioned ThyssenKrupp, but there are others as well in the manufacturing. We call them manufacturing. It could be those kind of businesses. Now, the next one is government. I mentioned those farms. There are IoT companies. These are new businesses, right? There are little startups who actually have these sensors which you put onto your vines in a vineyard. It detects the humidity, it detects the temperature variations. There's a sensor which you put in the ground. It detects the pH of the ground, and presumably you have all of that information and you know exactly what's going on in your vineyard, right? So that is using IoT for your improving your businesses. Similarly, governments are investing quite a lot in cities, smart cities. We have started to see how governments want to optimize the resources that a city has. Parking is one of them, example, because parking actually gets to all of us one time or the other. And governments know that, and they're working on that. Similarly, electric grid, smart grids, and all of those, these are all IoT applications. Healthcare is one vertical which has a lot of potential of transformation, given the expense of healthcare and how complex all the processes can be, and given the fact that you want to have real-time data to maybe call out issues that people have. So IoT can help there. And we have these three, well, there are many, but these three hospitals who are using IoT to actually manage their devices, which includes blood pressure cuffs and oximeters and so on. Okay, so how do you do that? Now, this is the part where I talk about how does a business think about IoT, right? And there are really 3 steps, and I'm going to go into more details here, but really there are 3 big steps that one has to think about. The first one is connect your things. Right? It's easier said than done, and I'm going to talk about some of the challenges that connecting your things mean. But when you have things in your environment, you want them to be connected to each other and to the network and maybe to the cloud, and you want to get all of the data together to look at the collective wisdom, the collective insights that come from those devices. So connect your things. The second thing is, once you have this data, you want to have insights from data. As I like to say, connecting a device to the network or each other, if you are not getting any insights from that data or that device, it's really a science project, right? It's really a science project, which is great, but the value of IoT comes about when you look at the data in aggregate, when you can predict things, when you can understand what is happening in the environment. Right? So connecting your things and then turning those insights, data into insights, and then finally transforming your business. So when you look at insights, light bulbs, we have seen those, light bulbs go off. Oh, I was missing this, and I need to work on this. So let's go a little bit deeper, one step deeper into this. What does connecting your things mean? When you put them together, the immediate benefit is more visibility. right? So imagine that you have a truck which delivers something to a customer. If you have a GPS on it and you have a GSM module on it, you can actually understand what is happening with the truck. You could optimize the path. You could optimize the trips. You could have more monitoring, so more visibility. You could also have the data tell you a different kind of story which could impact your ultimate objectives. So again, the truck example, you could put stuff on it, and if it is to be kept cold, you could put some IoT sensors around it, and now you can control the whole package when it arrives there. And then, of course, once you do that, your first level of value starts coming out. But really, as I previously said, the innovation comes out when you start looking at data and start getting insights, right? And these insights are mostly about data in the aggregate. If you have 200 trucks, each truck tells you a different story, but in aggregate, they actually tell you a much different story. In aggregate, they are telling you something which individually you'll probably never see, right? And then, of course, once you have, if this works, yeah. Once you have done that, then it's all about transforming. It's all about looking for that new thing. It's all about looking for that new business opportunity that you were missing because you did not have that insight. So these are kind of the very top level things that companies think of. Think of them as 3 steps of going through your IoT deployments. Okay, so now let's go and dig a little deeper into what does Microsoft provide to get these IoT projects up and running. Now, before we go there, I would want to be very clear here that deploying IoT is complex, right? If we are thinking about the small little devices on cows or dogs or whatever, putting it end to end is complex. It requires a lot of thinking. It requires a lot of development time. It requires testing. It requires understanding the device and the environment and all of that. And then, of course, security and privacy. So that's one interesting thing that we came up with. And the reason for that is many times it's about heterogeneity. It's about each of these devices being different operating systems, different designs. How do you put all of them together? It's a huge challenge. And how do you make sure that all of them together are secure, right? If you have this collection of 20 different versions of an operating system on these 500 devices, how do you even maintain them? How do you maintain the firmware on each of those devices? So the IoT deployments, very quickly, when you start looking at them at the enterprise scale, not as a science project, as an enterprise scale, they become complex. And we have some solutions for that. IoT solutions can be time-consuming. And the reason is, of course, the heterogeneity of devices and the kind of expertise that you require for its end-to-end operation. You have to have people who understand the device, the operating systems on the device. You need people who understand how connectivity is going to happen, how secure encrypted communication is going to happen between the devices, which might be very small, all the way to the cloud. You need to then think about what all insights or tools am I going to use on this data to understand what's going on. You possibly need a machine learning expert to look at the data and say, okay, I think I can build a model out of this data. So each of these are very specific domains which require a lot of different kinds of expertise and time as well. Many times, and this is important, many times what we see is deployments of these machines are already there. You're not going to take out and throw all of your physical machines and elevators and jet engines and bring in these new shiny IoT-enabled jet engines. You're not going to do that. There always has to be a plan to retrofit. And retrofitting is always hard because then you're also going to get new ones, the shiny IoT ones, right? So how do they coexist with each other? So planning so that you are compatible with current infrastructure. And current infrastructure, interestingly, if you go to manufacturing, for 20, 30 years, they have these machines which talk a protocol called CAN bus, which has their own software, a little controller, and not connected to anything, but just controlling those robotic arms and machines, and they were fine with that, within only that domain. So now what we are doing is we are saying, oh, okay, there is insight here. Can we now connect these machines to the next machine and to a gateway and possibly to a cloud? So the requirements on that machine, the machine was never designed to do that. And now we are saying we need to do that. So think about the brownfield, the existing machinery that is out there. And then think about the scale. Right? Deploying those 20 IoT devices in a lab, in a computer room is easy. It's, as I like to call it, is a science project. But turning that science project into 1.5 million deployed elevators around the world is hard. Just the fact that how does a device gets connected to the cloud? How do I put in that URI so that it knows where to go to? Is hard. Right? How do I do it securely? For a device which is deployed all over the world, not even physically controlled anywhere. It's hard. So scaling up devices is hard. IoT deployments is hard, not just from the registration and the provisioning side, but also from operations. Right? I have 1.5 million elevators, and now I want to update the firmware on these elevators. Good luck with that. If you want to do that manually, you'll take the next 10 years just doing that firmware update. And without any automated testing and visibility and orchestration of those workflows, half of those elevators would have corrupted firmwares and would be gone. Right? So these are complex issues to think of when you're thinking about IoT, scaling it up, and making it enterprise ready. Not to worry. There are a few things that we do which help in all of those scenarios. Right? I'm going to talk about intelligent devices to start with. I'm going to talk about this intelligent connectivity, which is the cloud and how that whole infrastructure works. I'm also going to talk about some of the intelligent insights, how you could get insights from those devices, and then actions. You just do not want to deploy elevators without being able to come back and act on it. So intelligent action. So we have offerings in all of these 4 areas. Okay, before I go further on, Windows 10 IoT is one operating system which we offer. And this is one of those supported operating systems that work with IoT, with Azure IoT. There are a bunch of other operating systems as well, and I'll go into those. But Windows IoT provides you with a first-class experience of being productive, because it has this familiar development environment, it has familiar user experiences which you are already used to, and so it does that. It also is trusted, so the security is built into the platform, Windows 10 IoT. The operating system is secure, and any of those provisioning flows and all can be designed on that platform. And finally, it is connected, so it supports a bunch of different operating protocols which different devices talk, and it can get connected very quickly. So Windows 10 IoT has been designed for that. Now, this is not just one Windows 10 IoT. We have a portfolio of 3 different layers or 3 different functionalities for Windows 10 IoT. At the lowest layer is Windows 10 for small footprint devices. These are small little cameras. IP cameras is one example. For which you will use the IoT core. Usually the differentiation there is you do not need a UI for that little device. And then if you need that UI, but a small UI, you go to the Windows IoT mobile, which essentially you can use in your barcode scanners and those kind of devices. And then the IoT enterprise is built for the jet engines of the world. Right? You deploy those IoT devices on, and they're powerful machines who have user experiences, but they're essentially connecting all of the IoT devices together. So we have this portfolio of Windows 10 in different forms which you can use in different kinds of devices. Now, on the cloud side, what we provide is Windows IoT Suite. And I like to step back here and tell you a story here. Right? So what happened was, as I mentioned, there is this device, there is this connectivity. Device has all of these different variations and heterogeneity, connectivity, and then connecting to the cloud. In the cloud, you have a bunch of services that you need to bring together, stitch them together. And we had a partner, early partner, very early partner, who said, okay, I'm going to do an end-to-end, all the way to visualization. And by the way, it might take 3 or 4 of my developers about a year to get it all up and running. Right? Because there is so much of different expertise. The machine learning model had to be built, right, based on data. The data had to be collected from the device. The device were Linux devices. And so there was no expertise to work on those, so had to be acquired. So we stepped back and said, that is not how you deploy IoT. IoT is the speed of light, right? You should, if you have an idea, you should be able to deploy it today. You shouldn't have to go into that year-long development cycle and then say, okay, I have a first working prototype, right? So that is when this thing came about, that we need to ship pre-configured solutions in source code form. And we looked at some of the normal patterns that people use IoT for. We came up with 2, the last 2 over here, pre-configured solutions. There is remote monitoring and there is predictive maintenance, 2 of these solutions. We said, okay, let's take predictive maintenance and let's build it end-to-end, right? So starting from the device to the connectivity, the security, the authentication, the cloud, stream analytics, the storage, the machine learning, all the way to visualization and alerts. Let's build it, package it as a cloud solution, put it on GitHub, and allow people to launch this from 0 to 100 in about 5 minutes. Yes, it is the pre-configured solution. It is exactly that. But it's the first prototype that you need for IoT, right? The first prototype that you need for IoT, all you need is an Azure subscription and click 5 buttons, and in 5 minutes you have an IoT deployment with a simulated device. You don't even need an actual device. A simulated C# device simulator, which is generating randomly temperature and humidity, sending it to the cloud. In the cloud, you have analytics working on it, you have machine learning working on it, you have visualization working on it, right? In 5 minutes, you can deploy it. And it's all open sourced. Open source on GitHub, you get that, you start working with that, and you start tweaking. I don't like the machine learning algorithm. Okay, go in and tweak the weights. I do not like the alerting thresholds. Okay, you can go in and tweak those. So that is what we shipped about 8 months back. Pre-configured solutions for companies who want to get into this transformation quickly so that they have the first prototype running like this. It did all of that, data ingestion, command and control, connectivity, management, all of those come out of box, and you simply deploy them today, and then if you like it, whatever you want to adapt, you start adapting. And we are continuing to add more to these pre-configured solutions. These 2 are the basic ones, and we are going to add more to it. Of course, security is extremely important to us. The platform security for Azure, of course, Azure is one of the largest cloud services out there, which is secured and constantly being secured, constantly being monitored. We are deployed in 30 data centers around the world. But then on top of it, our service also had to have the same kind of guarantees of security. So there are a few things here. We, of course, follow all standards. Like X509 TLS-based encryption on the channels, mutual authentication between the device and the cloud, and of course, the cloud has RBAC models for authorization. So there's a bunch of security built into the product. And time for advertisement. Tomorrow at 3 o'clock, there's another session that I'm doing for security. I'll go deeper into all of these topics. It's somewhere here, tomorrow at 3 o'clock. Okay, so then what you get is what you see on the left. This is out of box. 5 minutes, you get that out of box, right? You have a dashboard, which is based on Power BI. You have a simulated device, which is pumping out data, which is going through the whole pipeline of different services and ending up here. And then when you have more ideas, you have more business utility, you start adapting it, and it becomes something that is on your right, from the left to the right. And one last point, I think I'll make that point here. So this is an architectural view of the whole solution, the remote monitoring solution. Now, the interesting part is we know that you already have, a business would already have their existing business processes, like CRMs or inventory management systems or production planning and control systems. So what we do is, on the right, we provide a layer, an API layer, so that your existing systems, no matter what they could be Oracle, they could be SAP, they could be whatever, can then punch into that API layer and get access to the same data that your devices are generating. So in a sense, closing the loop. Right? So just to make it more concrete with an example, imagine ThyssenKrupp. They detected that issue, and they had a dashboard and an alert, but then their existing system was business system, CRM, not CRM, but the production planning system was something else, Oracle or SAP. All they did was they subscribed to an event from our system. When that happened, they generated the work order for the mechanic who would go down and do that maintenance. Right? So essentially, closing the loop by providing an API layer for your backend systems. Okay, so just to put it all together, you can work with any device that you have, any device, as long as it runs, it has a CPU and has a battery, can process things, and can run a C code. So we have our SDKs in these languages: C, .NET, Node.js, Python, and Java. All of these are open sourced on GitHub. You can get them, you can play around with them, and you can deploy it on your device. The operating systems we support are also any that you have. Of course, Windows, I talked about Windows IoT Core, which comes with our SDKs, but you can also take Linux. You can create a boutique Linux. A Linux, turn it down, as long as it can run a C library, put our C library there, and you're connected. And not just connected, you're connected securely to the cloud. So all of these operating systems, we also support very small MCUs, small little microcontrol units, which have only one executable file, like Arduino, if you're familiar with that. So we have a library which you can actually include in the Arduino code, and that then gets connected to the cloud. So, and all of this is open source. We have a gateway. So we also understand that all of your devices will not either be talking directly to the internet, are not IP enabled, or you might not want them to be connected directly to the internet. You might want to aggregate them in some place and then together talk to the cloud. It might also be a simple financial decision you make, right? Because cloud calls would cost you. You don't want 20 different devices making their own cloud calls. You want them to all to be aggregated in one gateway, and then that gateway makes that final cloud call. And we have an open source gateway SDK for Linux and Windows. So you can get that open source from GitHub. You can adapt it. It's a very simple architecture. It allows you device identification, device authentication. All of those security things are built into it. And you can deploy it in a location on a more powerful machine. And then different devices, which might talk IP, which might not. You might put a Z-Wave radio, which comes as a USB attachment, to that gateway, and now you have Z-Wave devices talking to the gateway, that talking up to the cloud. Right? So again, gateway is open source on GitHub. IoT Core, I think Windows 10 IoT Core, I talked about it. And finally, device management. So we understand again that when you deploy your devices at scale, and we're talking about millions, you want to have a way to control what runs on those devices remotely. You do not want to go to 10 million devices and start updating them, updating firmwares, right? So we provide a way to monitor the state of each device in real time or near real time, and we allow you to orchestrate these update flows. You update your firmware, you push out the firmware executable and then, or binary, and then that gets updated. You restart the device and you monitor what the state is, and then it comes back and tells you that my device is alive now. And this is the new version. So device management is a function. Another feature for device management is the fact that you can have topologies of devices. So imagine that this conference room, which by the way this conference center is a rather confusing place and you have to walk a lot. But all of these different buildings have different floors, you have different sensors, and you want to deploy an update only to temperature sensors in the whole conference center. But then update a patch to the humidity sensors only in this B building. Right? So we developed an attribute-based way to look at these topologies and to bring them down to those 10 million to 200 devices so that you can manage it better. So all of that is part of device management, which is in public preview right now. And then, of course, towards the cloud, when you connect your devices, you can connect your existing backend systems. There are a few examples here: SAP, Oracle, WebSphere, Informix, and many more, and you can connect them. And then we have in the cloud a bunch of other services. I think I mentioned that, but know that our cloud service is a scaled deployment of infrastructure around the world. So 30 is the number that we have right now, which constantly is growing. What does that mean for IoT? Right? Those elevators, I'm just picking up those elevators as one example. Those elevators are not just deployed in North America. They are deployed around the world. And they need to hit the data center closest to them. We have the muscle and we have the deployment footprint so that wherever you are around the globe, there is a data center with a minimal network call close to your device. Right? So, and then of course the backend and the different data is coming together, we take care of all of that. And of course, you'll hear a lot about our data platforms in today and the next of this week. We have this whole data platform. No matter what kind of data you have, be it relational data, document data, streaming data, any kind of data that you have, we have a solution for that. So you can actually use all of that part of IoT inside Flow. And then you could run stream analytics and machine learning, all of these data analytics tools on top of it. Right? And I think Gartner even put us in the leadership position over there earlier this year. Okay, now the thing that how we think about IoT is IoT has to be enterprise ready for you and our partners to actually start adopting. It has to be secure, end to end, so we take that very seriously. It has to be fast, so I talked about 5 minutes and you're deployed with an IoT, a basic IoT solution. It has to be open. We understand that many times you will not use the out-of-box solutions that we provide, but we should provide you with a lot of ability to work with open software or open gateways that you have. And it has to be scalable. It has to go from 20 devices in your lab all the way to 1.5 million, 2 million, 10 million, 50 million devices spread around the world. It has to scale that way. And something not mentioned here is standards. Right? We have to have our IoT deployment conform to as many standards as possible, and it does. So MQTT, AMQP are two messaging protocols that we support today. They're both standards. HTTPS is the other one. And we are constantly working to include more standard protocols to our gateways and our IoT hub. And then when you come on board, you also have support of this whole ecosystem of different kinds of people who understand IoT. And I'll tell you what it means. So the first two are the device partners and the gateway partners. So we have a program which we call Azure IoT Certified. So we work with device manufacturers, Intel, Dell, Raspberry Pi, and many more, 50 or so. We work with them. They give us their device. We put our SDK on it. We test it. And if it works with Azure IoT in terms of connectivity and can run our code, we certify it. Right? And then there's a web page. You can go and say, OK, I'm looking for a device with this much. These are the different features. It would tell you that these are all the certified devices that we know today work with Azure IoT. Not that others won't, but we have certified these. We have tested these, and we have certified these. So the Azure Certified program is there. We also have a bunch of network partners who work with us. Jasper is one. So they are the people who actually provision SIMs, for GSM networks. And IoT Suite works directly with a bunch of those technologies. We have the system integrators, which help us scale. And then we also have ISVs who actually make a lot of difference in this world. I looked at my watch, and I think I'm running very close to the end of our time. Here are some URLs. internetofyourthings.com is the place where you'll go. You'll find a bunch of those case studies which I mentioned. You'll find a link to actually do that 5-minute thing. If you have a subscription, you'll be able to simply launch your URL and your IoT suite in 5 minutes. And we strongly recommend you connect with the regional team, select a partner, and there's also a quick start guide over there. Which brings me to the end. I have a couple of minutes here, and then I can stay longer. If you have questions, I can answer. Please. Do you want to come here? So.
Test.
No? Oh. So let's do it one-on-one. Thank you very much. We are out of time. Thanks a lot. Thank you.